Hi guys, this is the video for chapter 13, lesson 3. It goes over range, interquartile range, upper quartile, lower quartile, and finding the outliers. So if I were you, I would definitely take out some notes and just record a few of these things because there's a few keywords here. And I'm going to use this set of data right here as my kind of sample data to use for an example as we go through this, because I think it's a lot more, makes a lot more sense if you have an example that we can kind of use to explain. So I have 3, 4, 5, 6, 8, 9, 11, and 12. So that's my set of data, and I have 8 numbers here. So we're going to take a look at what a range is, what a median and what we call a lower quartile. So I'm going to use LQ to represent that. An upper quartile. And then what we call an interquartile range and an outlier. So we're going to discuss what all these mean. Now, a range is really just the difference between the highest and lowest value. Highest and lowest. So if we were to look for the range of this set of information, we would just say that the range is 12 minus 13, which would be 9, right? So that's the range. There's a difference of 9 between the highest and lowest. The median, we don't really need to explain too much because we've talked about it a little bit. It's the middle value. So I usually like to count from both ends towards the middle. And so if I count both ends towards the middle, or I split this information in half, I have 4 numbers here and 4 numbers here. So I need to find what's the middle between 6 and 8, which would be 7, right? And if I couldn't just come up with that number by myself, I'd have to add the 2 and divide by 2, right? So add them up and divide by 2. So 14 divided by 2 is 7. So the median is 7. And then the lower quartile and upper quartile. Now, a lower quartile, if I say the word quartile, what word comes to mind? Hopefully you think quarter, right? So, and that's exactly what this is saying. This is saying, what's the lower quartile? Lower quarter. So splitting your information into quarters now. So you have 2 numbers here, 2 here, 2 here, 2 here. Split it into quarters. What is the lower quartile? So the median, that really means the median of the lower half. Median of the lower half. And the upper quartile would be almost the exact same thing, but just median of the upper half. Hence the name lower quartile and upper quartile. So looking at this, I would think, okay, lower quartile, what's in between 4 and 5 is 4.5. And then the upper quartile between 9 and 11 is 10. So my lower quartile is 4.5. My upper quartile is 10. And then your interquartile range is really just the range between the quartiles. So it's the difference between the lower and upper quartile. So that's the difference between the lower quartile and upper quartile. And so I could subtract, 10 minus 4.5, and that's 5.5. And then finally, we have the outlier. I like to describe the outlier as just a number that's either too big or too small that doesn't quite fit in with the norm of your information. But the problem with that definition doesn't give you a clear idea of what's considered an outlier, because you could have an outlier that is, maybe someone considers 20 would be an outlier, or someone else is like, well, 20 is still really close to 12. I think 30 would, anything beyond 30 would be an outlier. So your opinion of what an outlier really is not consistent and not valid for us to really decide what's an outlier. So therefore, the mathematicians have come up with an equation that comes up that basically tells you what the outliers are considered to be. So I would definitely put this down. To find the lower outlier, it's the lower quartile minus 1.5 times the inner quartile range. So I'm putting IQR to describe the inner quartile range. And then to find the upper outliers, what considers to be a higher outlier is the upper quartile plus 1.5 times the interquartile range. So all this information you just found is useful here because that's going to help us find the outlier. So my outlier, if I'm using this information, my lower quartile is 4.5. So it's 4.5 minus 1.5 times 5.5. So it's really saying it's 1.5 times smaller than your smallest number. So 1.5 times 5.5 is 8.25. And so 4.5 minus 8.25 is negative 3.75. So that's saying any number that's below negative 3.75 is considered an outlier. So anything smaller than negative 3.75. So if I put a number like 0 here, that's not, if 0 is in my set of data, that's not considered an outlier. It's not so small or so big that you would say, okay, that's kind of a random, weird number that doesn't really fit in with the norm of my information. So then the upper quartile is 10 plus, for the outlier, upper quartile plus 1.5 times 5.5. And so we would plug that in, and you would get 18.25. So this is saying any number above 18.25 is now considered an outlier. So earlier I put the number 20 here, and I'm saying, okay, would 20 be an outlier? Well, yes, because 20 is greater than 18.25, and so that would be an outlier. Now, these are just hypothetical numbers that we're putting down, a part of our set of data, but our set that's given to us is just this set right here, right? That's the set that's given to us. And so when we're looking at this, the question is, are there any outliers here? Is 12 or 3, are those considered an outlier? Well, no, because they are within the range of negative 3.75 and 18.25. So there are no outliers. Okay, so that's what I would say, no outliers, and that's it. Okay, I'm going to continue with this lesson a little bit by looking at our a practice worksheet. I don't have the study guide printed and copied up here, but I want to take a look at these stem and leaf plots. So with a stem and leaf plot, we still need to find the interquartile range and the upper quartile and the lower quartile and the median. So I'm going to write that stuff here. So the median, the range, the lower quartile, the upper quartile. So I'd recommend on your homework, you would lay them out like this: interquartile range, and then the outliers. Okay, so you're looking for all these things. Now, with a stem and leaf plot, it's easy to be confused with counting out your numbers because it's not just in order. So if I were you, I would recommend maybe writing them down out in a row and say, okay, this is 17, 18, 22, 23, 25, 26, 28, and then 30. And so maybe for you, it's just much easier to look at it as a row of information rather than a stem and leaf that can jumble kind of your recognition of what the number actually is. So the range is 30 minus 17. And so that's 13 is the range. The median is that middle number. So I might, I could count towards the middle that there's 8 numbers. So that means I would have to split my information into 2 halves where there's 4 numbers on each side, right? So that would be like right here. And I could cross off, beginning and smallest, biggest, smallest, biggest, smallest, biggest. Well, these 2 are my numbers in the middle. So it's between 23 and 25. And so my median is 24. Now my lower quartile is going to be in between my median of my lower half and my median of my upper half. So I have 22 plus 18. What's that? Is the median 20? Yes. So, or not the median of the lower half. Yes. So the lower quartile is 20. And then the upper quartile is 27. It's in between 26 and 28. And then your interquartile range is the difference between the 2. So it's 7, 27 minus 20. And now considering your outlier. So it's going to be 20 minus 1.5 times 7. And then the bigger end, your number is going to be 27 plus 1.7 times 7. Okay, so using our same equation that we wrote down earlier. 1.7 times 7 is 10.5. And so this here is 9.5 is your lower quartile. And then your upper quartile is 37.5. So looking at your information, do you have an outlier? Is there any number that jumps out that doesn't fit in the norm of your range of numbers? No, there isn't. So we're going to say no outlier. Okay, so it's important you find kind of the bookends of what you would consider the outliers and then look back at your data to say, oh, is one of them not really quite fitting in there? Okay, and that's all I'm going to do with you on this video for this lesson. I'm going to kind of tag team this lesson with 13.4. So 13.4 is about box and whisker plots. That's where you literally are just plotting your information as what we call a box and whisker plot. So let's go back to our example up here and say we found all this information. Well, to actually plot a box and whisker plot, you're going to do what we just did and find the lower quartile, upper quartile, and all that kind of stuff. So really the key things you're looking for, the median, the lower quartile, and upper quartile. And you're going to create a number line where you can fit the range of numbers onto your graph, onto your number line. So my smallest number here is 3. My biggest number here is 12. So I'm going to go up maybe by 2s, 0, 2, 4, 6, 8, 10, 12. Okay, so that's a number line where I'm going up by 2s. And then I'm going to plot first my smallest number, which is 3. Put a dot there. And my biggest number, which is 12. I'm going to plot those points. Then I'm going to plot where my median is, which is at 7. And then I'm going to plot where my lower and upper quartile is. So 4.5 and 10. Then I'm going to create a box around this. And that's where my box is. And then I'm going to draw a line right down the middle. And then I'm going to create my whiskers. That's why it's called the box and whisker plot. So those are my whiskers. So what this does is it actually describes your data as here's your smallest number. So I'm going to just give myself some room here by taking all this stuff off. Let's get some room so I can write this down. That is your lowest value. This is your highest value. And it's dividing your data into quarters. So here's 1/4 of your information, 1/4 of your information, 1/4 and 1/4. The middle is your median. And then, of course, what divides into the quarters, you've got your lower quartile and your upper quartile. And so those are the few things right here. These pieces of information, lowest number, lower quartile, median, upper quartile, and highest value is what you need for your box and whisker plot. And so you kind of have to do what you've done in chapter 13, lesson 3 first and know how to do that before you can create your box and whisker plot. So now let's take a look at an example. This is not on your study guide either. It's also just a practice. I don't think I'm going to create a box and whisker plot for all these, but basically I would recommend you'd have to put all these values, all this data in order, and then decide what is your median, what's your lower quartile, and what's your upper quartile. Find all those parts, and then you can create your box and whisker plot. So down here, we can use a box and whisker plot to compare information. So I'm going to do 8, 9, and 10 right here just to take a look at comparing information real fast. So looking at this is a box and whisker plot that describes corn yield by state. So this is 2003, year 2003, and then 2007, and it's looking at, okay, how much corn did the states yield in these years? Well, it looks like if we analyze this data, it says in which year was the corn yield more varied, meaning there's a wider range of information, wider range of yields of the corn, right? So it might be that different states yielded a different amount, and we're looking at all the states that grew corn and how much they actually produced. So so I would say 2007 had a wider range of yield because it goes from 70 to 150. The range is from 70 to 150, which is, if you subtract it, right, that's 80, the range of 80. Whereas in comparison to 2003, it is a yield where the range is between like 165 and 105. So the difference is like 60. So the range is smaller because the range and it's greater. Okay, so that's all you would really say. You'd explain why. 2007 because the range is 80 and it's greater than 2003. You might even say what 2003 is. How does the median yield in 2003 compare with the median yield of 2007? Well, they are pretty close, right? So I would say the median yield of 2003 is a little bit greater, is a little greater than 2007. But they are very close, right? The median yield is very close. And then it says, write a few sentences that compare the 2007 yields with the 2003 yield. I would say in 2007, the range of yield is greater. However, overall, 2003, the most states yielded more corn than in 2007. So you could say in 2003, maybe there is a greater amount of yield for 2003, and you can kind of say that the low, like it has a greater low range, greater lowest value, and a higher highest value. So you can just kind of write a few sentences, a paragraph of describing kind of the information and what that tells you. So you're using the box and whisker plot to describe the information it tells you. And so I'm not going to write all that down, but verbally I'm kind of explaining it here. So that's kind of an example where box and whisker plots are useful because it shows you like very quickly a visual representation of two sets of data that you can compare, okay, in a different way from, stem and leaf plots. So, all right, that's all I have for you guys.